This video focuses on the one-tailed confidence interval and standardized effect size for the independent t-test. The p-value is the likelihood of our data when the null hypothesis is true, so it helps us decide whether to reject the null hypothesis. However, all it tells us is the likelihood of dealing with a chance event. If we reject the null hypothesis, we should also describe the size of the effect we see, that is, the extent to which our results differ from the null hypothesis. Estimation, or confidence intervals, is one measure of effect size, or uncertainty. We rejected the null hypothesis that post-surgical adjustment was the same for patients in the new versus standard interventions, but how big a difference in adjustment might the hospital see if it were to implement the new intervention for all patients? The hypothesis test was one-tailed, so the confidence interval would also be one-tailed, providing only one bound on the estimate. The researchers expected the new intervention to result in better post-surgical adjustment, so the rejection region was in the upper tail, and we draw a lower bound. This is what the model of the null hypothesis looks like. The calculated test statistic fell in the upper tail, so the estimate hedges to the left to provide a lower bound. This is the lower bound formula. We begin with the point estimate of the parameter, our best single guess, and then subtract so many standard deviations from the point estimate. The t-value is the only piece that is not provided in the SPSS output. The mean difference was 7.3 and the standard error was 1.25. T is a tabled value found using the significance level and degrees of freedom. This gives us a lower bound estimate on the difference of approximately 5 points. Mean adjustment for patients in the new intervention is estimated to be at least 5 points higher than for those in the standard intervention. Another type of estimate is the standardized effect size. For an independent t-test, this is an estimate of the real difference between population means in standard deviation units, and it's calculated using sample data. SPSS produces standardized effect size estimates with the t-test output. Here is the effect size table for post-surgical adjustment. Cohen's d is the most commonly reported measure, but we can't use a pooled estimate of the standard deviation because the equivariance assumption wasn't met. Instead, we interpret Glass's delta, which uses the control group standard deviation as the standardizer, or denominator. The standardized effect size is the sample mean difference divided by the standardizer. We don't interpret the confidence interval because this was a one-tailed test. Using standards developed by Jacob Cohen, we interpret our standardized effect size to be very large. If the research hypothesis is one-tailed, the confidence interval should also be one-tailed. An effect size estimates the magnitude of an effect or difference. Measures include confidence intervals and the standardized effect size.